This is going to be a different talk, and I don't know what you guys do for a living, and normally when I give a talk, I kind of know who my audience is. So I apologize up front by saying that if I insult your intelligence by going too slowly or saying things that are obvious to you, I apologize. I'm just trying to make sure that you understand where I'm coming from, because this is a very important problem that we're facing, and I think it's important that everybody knows about it. Infrastructure. Boy, that's an exciting thing, right? That's not nearly as exciting as data analytics or big data or Internet of Things or stuff like that. It's really kind of boring, right? I mean, you got here using infrastructure, probably with transportation or somehow. You probably walked on a street or a sidewalk. That's infrastructure. The lights that are here in this room, that's infrastructure. We take all this stuff for granted because most of the time it works and it's not a problem. So the people that are not actually in infrastructure kind of forget about it. And that's one of the things that we're facing as a country is that particular problem that we're kind of forgetting about our infrastructure. But when you talk about infrastructure, if I asked you, say, hey, tell me about infrastructure, you'd probably say, well, that's bridges, or maybe it's airports, or maybe it's the power grid, or maybe it's roads. We have problems with roads. We have potholes. We have problems with our roads. We have infrastructure problems. I do want to mention one thing, and that's probably the most important piece of infrastructure that's been developed, it's certainly over the last couple of decades, and that's the internet. And the internet is not a physical thing per se. Physical things run the internet, but we're not going to be talking about that kind of infrastructure today, which is more data related and analytical related. We're going to talk about physical things today and the effects of that. So I just want to make that point. We can have that discussion another time. So here's one of the issues, and this is that comes out of a New York Times article relatively recently. People have been starting to talk about infrastructure, and one of the reasons they've probably been talking about it is because what's happening in Washington is they're talking about an infrastructure bill, $1 trillion infrastructure bill. So now people are saying, why do we need to spend $1 trillion on infrastructure? Well, if you look at how much money we as a country have been spending over the past 60 years on maintaining and building our infrastructure as a percentage of GDP, which is some measure of doing it. Maybe this is fair, maybe this is not fair, but the point is that we've dropped our investments in infrastructure over the past 60 years by 50%. So we're spending half as much now as we were in the 50s. You could argue we're being more efficient. That could be a good argument. You could argue we're not paying attention to our infrastructure, but if you pay attention to the headlines, I think you might be realizing stuff's falling apart. And if we're going to maintain our first world status, our ability to do 21st century stuff, we need the stuff that supports all that things, and that's all the roads, the bridges, the airports, and all that sort of thing. What's the secondary effect of what happens when you don't spend money in infrastructure? Well, it gets older. That's kind of what happens. You don't replace things, it gets older. You don't buy a new car, your car gets older. So this is another example out of a New York Times article talking about the age of assets as a function of time. And this is over the past 15 years and how much things have changed over the past 15 years. And you can see that everything's trending toward getting older, like we all are. So until you're replaced, you're going to get older. But the point is that this is an interesting aspect. This is the New York Times article about infrastructure. They talk about highways and streets. They talk about hospitals. They talk about power plants and distribution systems. Talk about schools and colleges. Talk about public transport, airports, ports, that kind of stuff. That's all there, right? This is what you think about when you think about infrastructure. Let me go back to that first picture. We talked about things like there's a light pole there. Well, there must be lights, and there's streets, and there's cars. There's something missing from that picture. What's missing is what's not in that picture, and it's what's underneath your feet. And that's water and its dirty stepsister, sewage. So those are the two things that people don't normally talk about when they talk about infrastructure. And I've got a couple of theories about that. One of them is that you can't see it. And if you can't see it, you don't think about it. And the phrase I use all the time is out of sight, out of mind. You go to your faucet in the morning, you turn it on, the water comes out. It's pretty good, it's relatively safe. It's there all the time. How often do you turn your shower on? The water's not there, not very often. And when you flush your toilet, the stuff leaves your house and goes to where it ought to be going, right? So you don't think about it too much. It's a piece of infrastructure that people don't think about or spend much time about. What's interesting about this particular picture, this is the Roman aqueducts, right? The Romans did a pretty good job of developing their empire over about 1,000 years, and one of the things they realized when Rome got to be about 1 million people is we don't have enough water here to keep our people around, so we're going to have to build these aqueducts. You can see these things. They're out in the open. These are visible. So people are kind of reminded every day, this infrastructure is there, it's bringing this stuff to us, but the pipes that are underground, you don't think about those very much. I had a second point, but I forgot what it was. Anyway, the point is that the Romans did a good job with their infrastructure. Let's talk a little bit about most recent things and things you've probably seen in the news. This is Flint, Michigan. For those of you that know about what happened in Flint, I'm not going to go into a lot of detail, but it started out as an infrastructure problem. It eventually became a corruption problem, which is really what caused the problem in Flint, and those people are going to jail, and that's a good thing. They shouldn't have done what they did. They were trying to do the right thing to begin with. What they were trying to do was find a secondary source of water for their people in Flint. And they made a change to that water, and the chemistry of that water was not what they expected it. They didn't pay attention to it. It wiped out all this stuff that was coating the lead pipes. Lead came out, and then they lied about it. That was the part that was bad. But the point is, two things. Infrastructure, it was an infrastructure problem that caused this, and all of a sudden people are now concerned about water infrastructure, which I think is a good thing. It's a bad thing for people in Flint. But the second thing is that people in the water and wastewater industry are inherently conservative. They don't want to try new things because you can only get in trouble if you try new things. If these things have been working for long periods of time, decades and decades and decades, hey, that's fine. I'm going to keep my job. I'm going to get to my pension and my fishing boat, and nothing's going to happen, so I'm okay. Don't try something new. That's the whole issue of trying to get technology infused into this industry. So that's something you may not face where you are, but it's something I face on a daily basis. Here's another example. This is in San Antonio, and San Antonio Water System is one of our biggest customers. They had a huge biblical rain there. I think it was 2 years ago, and one of their sewer pipes collapsed because they had so much rain in there and the pipe was not able to hold the pressure, and a big sinkhole opened. This is a tragedy. Sheriff's car driven by a lady drove into this hole. She died. So the point is that infrastructure problems are not just little things. They can be big things too. Flint's a big thing. People dying are big things. Okay, so we've got to be paying attention to our water infrastructure. Okay, so this is a really, really bad PowerPoint chart because you can't see it. But I had to steal it from somebody, so that's why it's here. But you can sort of see, these are histograms of ages of pipes in different places of the country. And one thing that's pretty obvious is the Northeast has had infrastructure in place for longer periods of time than, say, the Southwest, where I'm from, like Phoenix or San Diego. But the point is, in places like Baltimore or Philadelphia, those pipes are getting very, very old. I love a story. A good friend of mine, George Hawkins, who was the CEO of DC Water, tells a story about how he was replacing some pipeline in Washington, and they dug up some pipeline, and there was a guy's signature on the pipe, and the guy's signature was a pre-Civil War general. So that's how old the pipe was. So there's some infrastructure out there that's old, and that's something we have to be paying attention to. What else is going on? Well, it turns out that we are not doing very well in terms of our infrastructure. If you kind of look at how much it costs to replace and repair a pipeline, the number that I use typically, and it doesn't work everywhere, is about $1 million a mile. And it turns out there's 1 million miles of water pipeline in the U.S., roughly, give or take. There's 1 million miles of sewer pipeline, roughly, give or take, in the U.S. 1 million times 1 million is 1 trillion. As Everett Dirksen said, 1 billion here, 1 billion there. Pretty soon you're talking about real money. Now we're talking about trillions. So in fact, it is real money, and it is very, very expensive. So if you go back to that previous chart that showed how all this old pipeline is decaying, we're talking about big money, and we're not doing a very good job of keeping up with it. What are the consequences of that? Well, the EPA says there's about 75,000 sewer spills a year, and roughly 1 trillion gallons of raw sewage gets dumped into our environment and waterways. That's a lot. And it has a lot, it also has health benefits, or not health benefits, but health effects as well. People get sick from this. It's not a good thing. So what does the government do about it? Well, in 1972, the Clean Water Act came around. This is really what guides what's going on in sewer systems. And the Clean Water Act basically said you've got to stop dumping sewage in our water systems. The thing called the National Pollution Discharge Elimination System was developed, and those rules have then promulgated down to the state and local levels. So wherever you're from, you've got somebody that's in charge of making sure the Clean Water Act is being followed. In 2006, where I'm from, the state of California came out with what are called the wastewater discharge requirements, and the state of California said anytime you have any kind of spill of any amount anywhere, you've got to report it. And by the way, if you don't, it's a civil crime. You can go to jail. So this is now actually kind of it's crossing the nation, kind of like other things from California, like the hula hoop and whatever else came from California, Beach Boys, I guess. Anyway, New York's doing it, New Jersey's starting to do it, North Carolina, a lot of other states are realizing that it's time to start doing this sort of thing, so they're paying attention to it. Secondary part about this is, if we have some bad actors out there in terms of municipalities that are not paying attention, they will end up getting sued by somebody. And typically it's what's called a non-governmental organization like Riverwatch or Surf Riders or something like that. They will sue the people that are dumping sewage into the waterways. And what will happen is EPA will come in and they'll do what's called a consent decree, which is a legal agreement between the EPA and the cities. And there's $85 billion worth of consent decrees out there. That means that there's $85 billion that has to be spent by these organizations to fix their problems. If they don't, they get further fined. So there's a lot of money that's being pushed around in terms of this. What are the financial consequences? It's pretty serious. It's even more serious in the Northeast than it is in the rest of the country. And one of the reasons is, again, decaying infrastructure, and number two, there's been a flight of population from the Northeast to the South and the Southwest. So there's a lot of these cities that have these old infrastructures that frankly can't afford them anymore. And one of my best examples is another friend of mine, Jeff Wenberg, who runs the city of Rutland, Vermont sewage system, did a calculation of how much it's going to cost him to fix his problems. It's $125 million. Population of Rutland is 15,000 people. That's not going to happen. In fact, there's a whole bunch of cities in Ohio that have been put under consent decree, and they would effectively go bankrupt if those consent decrees were enforced. So we're really in a tough spot. We've got a problem with being able to pay for these bills. The bills are big. We're dumping sewage. Is there a better way? The answer is hopefully yes, and we're going to show you some things today about that. Here's the classical solution, and that's to dump concrete in the ground, fix the pipes, about $1 million a mile. In New York City, this would probably be $10 million a mile. Okay, let's talk about IoT. Now I'm going to talk about something you guys probably understand things about. Everyone's seen this kind of chart, right? Sensors, communication, analysis, decisions. Ultimately, the thing we're trying to do for our customers in the water industry is to give them a decision. They really don't care what goes on behind the screen that gets to that decision. They want to be able to have a decision they can trust. So in order to do that properly in the sewer world, you have to have sensors that are small, rugged, smart, and low power. So you can put them out in the collection system and sprinkle them out there and collect data and tell them what's going on in real time. That's not as easy as you think. And Stephanie was just up here talking about her startup, and I liked her talk. She started in 2017. I'm still a startup in the water industry. We've been around for 14 years. Communication. Communication has to be wireless. You have to be able to talk to these things wirelessly. It needs to be reliable. There's a hurricane headed towards South Carolina, North Carolina right now that will knock out cell systems, I guarantee you. And one of the reasons we use satellite for our communication is for that very reason. It needs to be ubiquitous. You can't have little bits of communication here and there. People have tried Bluetooth. It doesn't make any sense. It also has to be secure. The data analysis that provides the analysis for the customers, again, they don't necessarily need to know what's going on behind the curtain. It needs to be real time. It needs to be predictive. It needs to be able to say what's going to happen in the future. It needs to be integrated into their existing operating systems. If you try to walk into a water agency and say, I've got this great new toy, and by the way, you've got to retrain all your folks to use it, they will not buy it, I guarantee it. And the decisions, they need to be trustworthy. They need to say, okay, I understand where it's coming from. I understand the answer. I'm going to do things about it. It also needs to be simple and easy. Again, these are folks that are trying to do their job, get home, get to their retirement, and make sure that everything's okay. It also needs to be measurable. So it needs to be a way for them to get some feedback. So these are kind of the standard things that work out in the Internet of Things for sewers. This is how we do it. We have a monitor that sits on a manhole cover. It talks to the Iridium satellite system. That's our two-way wireless communication. The reason we use Iridium is because it's everywhere, and because the cool thing about Iridium is in sewers you tend to be in the lowest topological area. You're looking up all the time. That's a good thing because you're talking to satellites. When you're talking to cell phones, you're looking at low angles on the horizon, and that means if you're in a valley, you can't speak to them. And has anyone ever had a cell phone drop out? So that's the problem with cell phones. Also, and what happened with this hurricanes that happened last year in Florida, the cell phone systems die, and that's when they want to know what's going on in their sewer system. So what I would tell the people that our customers are in North Carolina, South Carolina right now, look at all your data and find out where it is and clean out where you might have problems and make sure you have enough capacity to absorb any of that water that gets in there. These go onto our cloud in San Diego. We bring in real-time data, for example, weather data, temperature data, humidity data. and then we provide that information to our customers. So this is a full drop-in, you don't need anything else, Internet of Things solution for sewer systems. And this, you guys, this is like simple stuff, right? You're right. But for this industry, it's a revolution, and it takes a while to get them to understand that. Here's an example. This happens to be San Antonio, where they have 500 of these systems deployed, plus a bunch of other sensing systems, including stream gauges and water, rain gauges as well. This is kind of what it looks like. And this is the kind of data we look at, and it's time series data. Again, very simple stuff, and I apologize for this, but this is how simple things are. The information you get out of a sewer is what's the water level look like as a function of time. Kind of looks like an EKG, actually. This is actual data from a sewer. On a daily basis, it goes up and down based on what's going on. There's more usage in the morning, more in the afternoon, and this is what the overall pattern looks like. And here are some examples. That's a normal heartbeat. That's grit buildup, that's a blockage upstream, that's a blockage downstream. So you can actually start telling what's going on in the system based on what these patterns look like. This is not rocket science, but for them it is. So again, we're doing other things where we're integrating a lot of data in there, but the point is give them a good, trustworthy decision. Some quick case studies, I got about 10 minutes left. This is Hawthorne, California. If you've ever flown into LAX airport and you're sitting on the left-hand side of the airplane as you're coming down, that's where Hawthorne is, right before you hit the runway. That's where Hawthorne is. The Beach Boys came from there. Anyway, they have two full-time field staff, 90 miles of pipeline. It's a small system. They were getting 10 spills a year. They put these monitoring systems in there and responded to them in real time. They reduced their overflows by 99% over the past 10 years, which is phenomenal. They've had one spill in 10 years, which is pretty great. And it's just a tremendous change in how their response has been. They've saved over $2.5 million based on that. San Antonio, I mentioned them earlier. They're looking at, because they're under consent decree, the consent decree says you must clean your sewer pipelines every so often. We went to them and said, how about if you forget about that for a second and use data to tell you when to clean your pipeline instead of doing it based on a calendar. And what they found out was when they put these systems in and responded to the data as opposed to the calendar, they were able to reduce their cleaning by 94%. Again, these are big numbers. These are big changes. These aren't 10 and 20% differences. These are huge changes, and it's an example of how data and analysis done properly in water systems can have a huge impact. They're looking at saving $3.1 million over the next 3 years. Escondido, California, where our company is, spill didn't happen in 2017 because they had a pipe collapse, and they were told by our system that the pipe collapsed. They went and fixed it. No sewage went into any of the industries. This is an industrial park, by the way, and it happened at 2 o'clock in the morning. Nobody was there. Those things all would have been flooded out with sewage. The utility director told us that we saved them $6 million in that particular situation. So again, knowing what's going on out in your system and getting that data in and doing something about it is really what you're looking for. Here's a capital project example. If you've ever been skiing in the Rockies, Mount Crested Butte is a ski area. They've got 6,500 year-round residents. They were under consent order by the state of Colorado in 2006 because they had a sewer spill. The standard solution was to replace the pipeline for $10 million. I can't tell you the whole story because I don't have time. It's a good story, though. Come to me afterwards. I'll tell you what it was. We ended up putting a system in for them for less than $100,000, and it solved their problem. So the cool part was they got pulled out of the consent decree. The state said, yay, you're not spilling sewage anymore. They can replace their pipeline at their leisure as opposed to under force, and they've had no spills since the installation. So again, a great application of data and analysis and decisions, IoT, for this particular world. Where are we headed? This is a bit of a complicated chart, but the point is that if there's inputs to sewer systems, there's transports, and there's outputs, and if you can monitor these things in real time, you can do a much better job. How am I doing on time, Paco? Okay, all right. But those M's are places where we'll be monitoring. The old way of doing things was gray infrastructure. By gray infrastructure, I mean concrete. You put concrete in the ground, you fix the pipe, you make it better. You've probably heard of green infrastructure. A lot of our cities have been paved over, so there's no ground for rainwater to go in anymore, so it ends up going into channels, and those channels put the water someplace where it's not naturally meant to be. So people are doing gray infrastructure now where they're opening up places that have been paved and unpaving things and letting the rainwater go in and get absorbed, which is a much better way of doing a thing. The third thing, which is the third leg of the stool, what we're talking about is data infrastructure. If you know more about what's going on in your system, you can make more intelligent decisions. And that's kind of a very kind of a broad statement, but in fact, we've shown in a lot of cases it's true. We're also working with Congress. Believe it or not, one of the problems with consent decrees is they are based on old technology and old ways of doing things, and we're trying to get the U.S. government to actually say, you know what, data infrastructure is here and it ought to be used. And in fact, this language got put into the Word of bill on the House side. It's already been passed. It's going to the Senate pretty soon and hopefully be signed into law that will actually encourage people to use digital monitoring technology in water and wastewater systems before they spend a bunch of money on concrete, which I think is a really good idea. It's a way of optimizing their system, so we're working on that as well. So what's the future of smart water infrastructure? There's budget pressures. Gray tsunami means there's people like me that are retiring from the water industry. Aging infrastructure we talked about, and there's increasing customer expectations. Because of what you guys do, everyone assumes they can pick up their phone and they get answers right away. And by the way, that's a good thing that you're doing this, because people are saying, I want to know about what's going on in my collection system, my distribution system, or how's my water quality right now, or that sort of thing, or how much water did I use last week? This is helping do that, so I appreciate what you guys are doing in that area. But customer expectations are now in the 21st century, finally. So how do we solve that? Real-time data, network sensing, optimized maintenance, cost and risk reduction. And before I say goodbye, because I want to tell you where I was yesterday, that's where I was yesterday. So anyway, thank you. Any questions, comments, concerns? Come on now. Sir. So the question is, what other aspects of infrastructure are ripe for this kind of analysis for cost savings? I think virtually anything that involves changing and building things, if you can monitor, you do a better job of deciding when you can make those changes. For example, the whole point of monitoring pipeline is to extend the lifetime of that pipeline instead of just replacing it. And the number I've heard from people in the industry is 75% of the pipeline they replace didn't need to be replaced. So they just do it just to be safe because they want to be conservative. They don't want stuff to break. So I think if you monitor stuff like bridges and that sort of thing, that's probably something you can do and do a better job at. Yes, sir.
Do you think now that you have some successes that the reluctance to change is modifying the change?
Yeah, it is, but it's slow. And in fact, I would encourage anybody here that needs a job, the water industry in particular needs people. And it needs people like you that are thinking about how to solve problems using information and data. So I'd like to encourage anybody here in this room to look into their local water agency and see if they've got a data analysis position open. But it is changing. It's slow. Anything else? Okay. Thank you.